Hello everyone. So this video is in continuation with the analysis of multi-story frames or multi-story buildings, part 3. So in the part 1 we have calculated the loads coming to the frame. In the second part we have analyzed the structure under vertical load using substitute frame method. In this video we are going to analyze the same frame under lateral load by portal method. Okay, there is another video also in portal method I have already solved. You can refer that also for more understanding. So analyzing this structure directly, I will go for solving without giving any introduction on this portal method. You can refer that video for more about portal method. So this was the frame that we have considered with height 3 meter each and the span were 5 meter. Okay, so we have already considered the vertical load. In this I'm only considering the lateral load that we have calculated, the earthquake load, because the building is present in zone 3. So we have considered zone 3 and we have calculated the forces that is coming to the frame. So here it was 88.04 kilonewton. So how these values have come, you have to refer part 1, and this was 35.35 kilonewton at this level. Okay, so let me put the names of the joints A, B, C. This was D, E, F, and this is G, H, I. Okay, these are the joints. So first we'll start at roof level. So at this level, so we are going to calculate the shear in columns. So let me put this shear as so let me draw here, or I can put here. So these are the contraflexure points that we are assuming in the portal methods, right? In the beams also at the midspan and for the columns at mid height. So this is our, because let me put as this is S1 for the first story, S1G. Okay, this is the shear in the column. So let me draw a bigger picture of this. So these are the mid height and mid spans where we are considering the contraflexure points. So at this we have the column S1G is our column shear. This is S1H. Let me put this is S1I, because GHI this is, so I am putting the names like that. For the second story, I'll put as S1D because this is D, and here S, let me put S2D. Okay, so for this column, this will be S1E and this S2E shear. So this we are going to calculate now. S1F and this side S2F. Okay, and for the beam shear, so let me take this as V for shear, for the beam DE, this is for EF. Okay, so this is for VGH and this is VHI. So for calculating S1G, this, okay, S1G, So formula is the horizontal force H1, which is 88.04 into L1, and L2 means the lengths, that is the lengths of the members that is touching that point G, by total summation of L. So here S1G horizontal force is 88.04. So this is the force that is coming, okay, 88.04 at the roof level into length L1. So if we are taking, so this is the G point, this is D and this is H. So this is what I am considering S1G, right? So this is the horizontal force H1. L1 is, this is our length L1 from the mid span we are taking. Okay, so 5/2 plus, there is no span in this direction, the other direction. Okay, there is no span here, so only one direction, so 0 the other direction, by the total length. That means this L total length 5 meter plus 5 meter. So 5 plus 5, 10 meter. So this we got 22.01 kilonewton. This is same as the other end also, S1I. Okay, so we got the shear. Now from this, let me calculate at S1H also. Okay, S1H will be same, 88.04 is the horizontal force at that level. Here the length will be 5/2. So if you are coming at the H point, so this is G, the counterflexure point. So here 5/2 at the mid height, and this is I. So this is also 5/2 at mid counterflexure points. So because two members are joining, but in the case of G there was only one member, only this direction. Here there was no member. So 5/2 by 5/2 by total length, again 5 plus 5. So here we got 44.02 kilonewton. Okay. Next, we are going to calculate the moment in the column. So now we are in first level, roof level only. So coming to the moments, it will be, let me calculate M1G, that is the moment at G point here. So what will be the moment here and in this column? S1G, the shear force, into the vertical distance, perpendicular distance. Force into perpendicular distance is the moment. So S1G into this distance is the mid height. That means 3/2. Total height is 3 meter, 3/2. So we got 22.01 into 3/2, which comes 33.015 kilonewton meter. Okay. Now coming to moment at 1H. So S1H into this perpendicular distance, S1H into again 3/2. So we will get 44.02 into 3/2, 66.03 kilonewton meter. Okay. Now if you see at joint G, summation of moment at joint G should be equal to 0 at this point. That means moment about G, 1G, okay, in the column, plus moment about GH in the beam should be equal to 0. So we know the 1G, the column moment. So in the beam, what is the moment? Minus M1G, which is equal to minus 33.015 kilonewton meter. Okay, so we got the moment in beam also. Similarly, at M1H we know, so summation of moment at H is equal to 0. This implies here at edge there are 3 members, 2 from beams and 1 from column. So M1H the column plus MGH plus MHI is equal to 0. So from here I can write MHI is equal to minus of this, minus of, so MHI is minus of MGH, which we have calculated. So minus of minus 33.0515 is plus 33.015, then and the HI, which we have calculated 66.03. So we got minus 33.015. Okay. Similarly, for moment at 1I, the end column, 1I is the shear 1I into 3 by 2. So again same, we'll get 33.015 kilonewton meter, and the moment in the beam 1H will be, because summation of moment at I is equal to 0, so minus of 1I, so is minus 0.30 minus 33.015 kilonewton meter. Okay, so we got the moments in the columns. Now coming to the shear force in the column, first we have to calculate the, because column we have calculated the shear force in the beam. Okay, shear force in beam. So VGH, because we are calculating for the roof level, so VGH is the shear force between G and H. So what we are going to do is, we know it is dm by dx. Okay, so the moment difference is 33 point. So let me draw the column moment, what we have got right now. So here we got moment, here is 33.015, and here also. Here we got 66.03. Here again 33.015, 33.015. Okay, in the first level. So this is column bending moment diagram. So we will be also going for the ground floor before that. So next is for beam. So I'm not going to put there, differently I'm going to draw for clarity. Okay, so for the first, here also we got 33.015 because the summation of moment was 0. Okay, 33.015. So moment at GH, this is 33.015, HI also 33.015. Because the spans are same, we got same values. Okay. Now coming to the shear force diagram. So if you see, this is beam BMD, bending moment diagram. So 33.015, this value and this value. So I'm going to add 33.015 minus of minus, because one is positive, one is negative. So 33.015 by total span is 5 meter. So we get, if you divide this, you'll get 13.206 kilometer. So this is your shear force in the beam. So this shear force will come as, so if this is the beam, the column is there, right? G, this is D. So this shear will act as an axial force to this column. So this is equal to the axial force in column. Okay. Next we are going to level 2. So I'll just write ground floor. Same, we are going to calculate shear, then moment, and then the shear force or the axial force in the column. So first, the total horizontal force at this level will be, so it will be H1 plus H2. So that means first level was 88.04 plus 35.34 total horizontal force summation. So H1 plus H2, which is equal to 88.04 plus 35.35. Okay. Now this we are going to distribute. So at 2D, so this one. Now I am going to calculate 2D, 2E, 2F. Then I will calculate the moment. S2D into this distance will get the moment. From moment, again summation of moment at D is equal to 0. We'll get the moment in the beam DE. Then from DE moment, we'll calculate the shear in the beam. That's it. Okay. Same procedure we are going to do for this ground floor. So 2D will be 123.39 into, so 5 by 2, because only one member is going to come, the other member is 0, by 5 plus 5, the total length. So you'll get 30.85 kilonewton. This is also equal to the last member shear force. And shear force at 2E will be 123.39 into, there are two members, so 5 by 2 plus 5 by 2 by 5 plus 5. So you are going to get 61.695 kilonewton. Okay. So from here we are going to calculate the moment. So moment at the first column is S2D into the height, mid height, so 3 by 2, so 30.85 into 3 by 2, you are getting moment 46.275 kilonewton meter. So summation of moment at D is equal to 0. That implies moment at in the beam DE. Okay. Moment in the DE is, it's D, right? Okay. Minus 46, because moment is minus moment about 2D, because this summation is 0, so minus 46.275 kilonewton meter. Okay. Next is moment at 2E. So shear at 2E into 3 by 2, 2 is 61 point, this one, 695 into 3 by 2, you are getting 92.54. 92.54 kilonewton meter. So now we have to calculate the moment in the beam. So moment about is ED, right? Plus moment about 1, 2 E plus moment about EF is equal to 0. So moment about EF, this is DEF, right? Notation DEF, yes. This DEF. So we are going to calculate the moment in EF. So this will be minus moment in 2E is this, this is minus 46, no, it's minus 92.54. Then there is so we got, and there is also a moment about the upper column, because there are 4 members are coming. So 1E, there are 4 members coming, right? If you see at E point, 1, 2, 3, 4. So 2 beams and 2 columns. And also I have done here mistake. Wait. So this is moment about D is 0, but here there is 3 members coming. For the upper story it was 2 members, so directly we wrote minus, but here 3 members are coming. So it will be moment about DE plus 1D, the upper story, and there is also the below story 2D, I'll write, equal to 0. Okay, so moment about DE will be minus 46.275 minus the above story moment 33.015. So before it was, you can see 33.015, and now we calculated the moment 46.275. So we will get minus 79.29 kilonewton meter. At this point we have 4 members touching at E, so we have minus 92.54, then minus 79.29, because from the beam DE, then we have minus 66.03 from the upper column. Okay, 66.03 from the upper column. So from here 66.03, from here from below we have got this 46.275 is 2D. So this 92.54 2E. So 92.54, 79.29 from the beam, and then 66.03. So minus 92.54 minus 66.03, and this minus 79.29 will be plus, because this is negative, so negative will come the other direction, positive. So you will get 79.29 kilonewton meter here also. For this beam also you will get 79.29. So we have already calculated. Now we are going to calculate the shear in the beam DE. So shear will be 79.29. We have the difference between the two ends, minus of minus plus 79.29 by the span 5 meter. So you will get 31.716 kilonewton. Again, this will be your axial force for the column. So coming to this bending moment diagram, For the below column, we got 2D, this one 46.275. Okay, then this is 2E 92.54. Okay, this is the complete bending moment diagram for the column. Coming to the beam, we have calculated the moment, and DE is minus 79.29. Okay, this also we got 79.29. Okay, so this is our column and beam bending moment diagram. So for this bending moment, we will be, this is due to lateral load, we'll be designing the elements. And coming to the columns, so for the column, this GD column, so we have moment is 33.015 we have to design, and for the axial force of the shear that we calculated 13.026. Okay, this 13.026 kilonewton you have to design. Then for the below column DA, we have to design for moment 46.275, and the axial force came 31.716, right, this. And also we have to add the axial that is coming the above column, because axial force from the above column will also transfer to the below column. So plus 13.206 I will add. So we'll get 44.922 kilonewton. Okay. Coming to the intermediate columns, HE. So we are going to design for moment. Again, say, so it is 66.03, okay, and 92.54 for the below one. So 66.03, and for EB, we are going to calculate for moment 92.54. Coming to the axial force, we have 0, because if you see here at the intermediate point, so if you, so we have 3 points G, H, I. Okay, so we have shear here, shear here. So when this shear is transferred here, you can see like this. So because our value is same, so in the first we have 13.206, so 13.206 downward, and this is 13.206 upward. So in the axial force, to the column there is 0, because plus and minus 0. Okay. So for intermediate columns, we are not going to have any axial force. Okay. So these are the forces that in the next video we are going to design the members. Hope this video is useful for you. Thank you for watching.